Hello and welcome back. In this video, we'll talk a lot more about what might be a terrifying subject for you: statistics. Now, rather than overwhelm you though with complex terms and confusing symbols, I'll be looking to just help you make some decisions about your dissertation and how best to conduct your study. Now, I should say that we won't be able to avoid those terms altogether, but there won't be any confusing symbols. The terms, when used, will be aimed to help you make those good decisions I mentioned. First though, just a little bit of background information for the sake of context. Dissertation projects can be qualitative, quantitative, or mixed methods in approach. And two of these options involve statistical analysis, and only purely qualitative studies get to avoid the difficulty of this work. Now, before you feel envious, know that qualitative analysis might be even more difficult. We help you to unpack it in a few other tutorial videos. And if you stumbled here by accident, know that we're one of the only consulting firms that can take on the really difficult coding we describe in these qualitative analysis instructional videos. But for now, let's get back to stats. And it can be like a foreign language to a lot of people, even if you've taken courses in it. So being away and not practicing can leave you less than fluent, trust me. Just like the vocabulary items, verb conjugations and syntactical concerns associated with the language, statistics offers a number of challenges too. First is operationalizing variables. This means that you have to figure out just what a variable means, in concrete terms. If you're looking at the effectiveness of a curriculum for students, what does effective mean? Does it mean that it increases student performance? Okay, that's great. Does it increase performance more than a different curriculum addressing the same skills would? Or is it just any increase? Now, in addition, students are tested a lot. What will you use to determine that increase in performance? Now, this step can be tricky, and getting help at this stage of your dissertation is natural. So in short, there's just a lot to consider. And the last item I mentioned pointed in the direction of another issue, and that's selecting instruments. Once you operationalize a variable, you have to figure out how to measure it, how to turn it into numbers. Now, this is straightforward when it comes to performance, as that's often quantified naturally. However, what about self-efficacy or acculturation? Fortunately, instruments exist that take care of this measurement for your dissertation, and we can help you with finding these for you. Now, we definitely suggest that you select an instrument that already exists and has been pre-validated. It's possible to design your own, but it comes with strings attached. You have to conduct a pilot study to first determine certain types of validity and reliability for your investigation. More on that later. The final step is planning your statistical analysis. How do you know what to do? There are so many tests to run, and while you remember some of the names of them, accessing in your memory just which ones work in which situations, well, that's much more difficult. So in this video, we'll take a closer look at two of these concerns. In our earlier module on qualitative methods, we talked about the strengths and weaknesses of a qualitative research approach and of a quantitative approach. Now let's review those here briefly, and then put them in the context of a study that you might be conducting. Now, you'll be able to see the differences right away in many ways, because they're opposites. So let's start with qualitative research. Okay, so here you'll see that qualitative studies can be really powerful, partly because the research isn't limited by more than scope in the responses that can be drawn from it. It moves inductively, and so no hypotheses guide it. As a result, it's flexible and open-ended, and it uses language rather than numbers as the data to be analysed. Now, for all these reasons, a central strength of qualitative studies is that they can be great for exploratory research, where very little is known and where initial work is needed to better understand a phenomenon. Those strengths carry weaknesses with them though, so be warned, because language is involved, and often through interviews, at least in part, sample sizes are really small compared to quantitative studies. Analysis of a huge amount of data can be just as difficult, and gathering it might be even more time intensive. Because sample sizes are small, generalising from a sample of participants to an overall population isn't possible. it can't be assumed that the sample is a representative one. For that reason, and because qualitative research proceeds without established variables, it's also not possible to determine clear relationships among any variables or constructs. Participants might perceive a relationship, but that's not the same. Again, quantitative studies can be opposite in many, many ways. Let's start with relationships. Quantitative studies can determine them. Specifically, statistical analysis often moves deductively, knowing in advance what the variables are. They set out to measure those variables in particular, and they do so in numerical fashion, usually with pre-validated survey instruments. Again, more on that soon. Now, as a result, data collection and analysis are much less time and resource intensive, and so large samples are possible here. And that's great, as long as sampling is done sufficiently and in the right ways. Then generalising to the broader population can also be done. This makes the results of quantitative studies particularly strong, though with those strengths come some weaknesses. Now, notice that I've been saying relationships to talk about what quantitative studies can determine. In most cases, causation is not one such relationship. Without an experimental design or complex time series methods, it's not possible to determine causation. Instead, quantitative studies most often determine only correlation. In our statistical consulting, we often find that candidates struggle with language use in the dissertation, particularly with research questions and hypotheses. And we'll talk more about this when we get to specific designs. Finally, because quantitative studies have such large samples, they focus on people as members of groups rather than as individuals. Outliers then, or those people who respond differently, aren't examined more closely. That is, we don't get to know generally why they responded differently. Now you might be thinking, this is great, and yes it is, but what should you do? In our video on qualitative research methods, we looked at a research gap related to nurses and turnover that lent itself better to a qualitative methodology. Now let's say you've actually moved on to a new topic and to a new programme altogether. Let's also say that you're now studying education. Specifically, you're really interested if peer mentoring programmes for new college students help them become more successful in school and more likely to remain and get their degrees. A comprehensive review of the literature reveals that peer mentoring programmes can differ from one another quite a lot. Some focus purely on navigating courses, and others help them to fit more fully into the culture of the college and the particular university campus. A qualitative approach would be wonderful for your research in some ways, particularly in helping you understand how students experience an intervention, if they feel it's effective, and how they perceive that they can navigate the new environment of the school because of the intervention. Unfortunately though, you wouldn't be able to generalise from your small group of students to the broader group of freshmen, and you'd not know if the programme was effective, even for them. You'd know only if they feel that it is or will be. Now, of course, effective could mean many things, but let's remember that your concern earlier was about whether it would help them stay in school. A further dig into the literature can be helpful, and let's say that you find that non-academic variables such as self-efficacy can be particularly powerful predictors of student retention. With a quantitative study, you would set out to measure those specific variables: participation in a peer mentoring programme and self-efficacy. With solid measurements of each, you'd be able to use statistical analysis to determine the relationship between them. Insofar as self-efficacy is bound up with retention, you can also develop some sense of how effective the peer mentoring programme is. Because you'll be working with a larger sample size for this study, using a pre-validated instrument to measure self-efficacy easily, you'll also be able to generalise from your sample to the larger population of freshman students at the school. Now that sounds great, doesn't it? Because between these two options then, it sounds like a quantitative methodology would give you a clearer picture of what you're after. It might seem as though the decision made itself here. Remember that a qualitative study would have worked well here too, and it would have just answered a different set of questions and in a different way. Now what's wonderful here is that your interest plays a key role. In our dissertation consulting work, particularly at the early stages, we prioritise learning more about our clients' interest for research. You'll be living with your study for a while, so, well, it's important to love it. And if you're still not sure what would be best, then please give us a call. We can work with you to unpack your research gap and explore your options, giving you a clear idea whether your focus points towards a qualitative, quantitative, or even mixed methods approach. Mixed methods studies, I should say, can be particularly exciting. They have some drawbacks, but they combine the benefits of a qualitative and quantitative research approach. So see our video on mixed methods for a better sense of the possibilities. Oh, and please note too that regardless of what you decide, we can help either way. While you might have a preference for one methodology, your committee members might too. And this is especially the case with the major online universities. And we can work with your precise dissertation to provide the help that will allow you to navigate the competing aims here effectively. So let's say that your committee is on board with a quantitative approach too, and so you're ready to move ahead. Well, what's next? In your foundational work and then in your methods chapter, you'll need to discuss research design right after you talk about methodology. But let's stop and talk about just a couple of things that will be needed for your study. All along, we've been talking about a large sample size relative to qualitative studies as a benefit of quantitative work. However, many candidates do struggle to have access to a sufficient number of participants and so determine that a qualitative study will be needed. Many candidates reach out for dissertation help only when they've run into this sample size obstacle. So we often provide assistance with this very issue. If you're at the start of the process, please let us know. We actually start our topic development process for our clients with an in-depth methodologist call for this very reason. Operating even at early stages with a sense of what will be working for a methodology will be really important. And one common question is, how large a sample do I actually need? That brings us to a power analysis. There are two kinds of power analysis, actually. The first and most common is called a priori power analysis. Just like its name would suggest, it's done outside the experience of the study. It tells you how many participants you need to reach a threshold for statistical significance. And this calculation is usually done in G power. This calculation depends on a series of inputs, including for statistical power and confidence interval, and the output of the calculation is a minimum sample size to achieve statistical significance for your particular study and the testing you'll be taking on. Now, it's a tricky step, so we often provide consulting with this critical step in developing statistical methodology. The other kind of power analysis is an a posteriori, or more commonly post hoc power analysis. It uses as inputs the actual size of your sample and your statistical testing to determine the statistical power associated with your actual sample size. In our consulting, we're asked about this less commonly, but your dissertation committee can ask for it if you achieve a sample size that is lower than the minimum sample size called for by the power analysis. The next concern for you here is actually related to the first, instrumentation. We'll need to back up just a little bit and talk about variables. They can also be categorical, also called nominal, ordinal or continuous, also called interval. And to make it clear right away, let's apply these to the variables for our example study. The independent variable will be participation in a peer mentoring program. And notice that it's not how long the program is, how long the sessions are, or anything like that. It's just participation. So as such, our possible values here are yes and no. In most kinds of quantitative studies then, students would be placed into one of these two categories. As such, it's a categorical variable. Self-efficacy is just a little bit trickier. We'll get into instrumentation in a moment, but let's say that self-efficacy is tested by a number of 7-point Likert scale items in a survey. Most often, these data would be treated as continuous. Continuous or interval variables are measured numbers along a continuum. Likert scale data are actually ordinal in nature, and there are a few strange quirks like this for a dissertation. Talking to a consultant about them can help to shed light on them. Age is a more traditional continuous variable, as would be grade point average and a number of other variables. Most, but not all surveys, measure variables as a continuous one. Because the nature of your variables helps to determine what statistical tests you'll do, and because what statistical tests you'll do determines your input for a power analysis, it's important to work backwards here. Now that means engaging with statistics may be a bit sooner than you planned. There's another concern related to instrumentation. There has to be one, right? In particular, there should be a pre-validated instrument to measure any variable you're looking to measure. Pre-validated means that the instrument has already been determined to be a valid one. It measures what it means to, in this case self-efficacy. And in addition, it measures it each time it's used. So in other words, it does that measurement reliably. While it's possible to validate an instrument that you create, your committee will recommend that you use a pre-validated instrument with established psychometric data, and we do too. In situations where you're determined to create something new, or if you're modifying an existing instrument in any significant way, you'll need to take on what's called a pilot study. Requirements for a pilot study differ depending on your program or even your committee and the nature of your study. For sampling at least, things are pretty consistent. A smaller sample than the one that will be used in your main study appears here, and you'll need to recruit approximately 20 participants, though sometimes the rule is a 10% rule, and that is that the sample size for a pilot study should be about 10% the size of the main study's sample. Now I should note that the sample for your pilot study can't be part of the sample for your main study. Testing is where it gets interesting and potentially quite complex, and a lot of work as well. So indeed, the whole dissertations can be devoted to the development of a new instrument, and many clients working on quantitative dissertations reach out for help at this stage. In these instances, the testing tends to be more robust. And in other situations, a candidate is able to proceed with just reliability testing. This is done specifically through Cronenbach's alpha, and it tests what's called internal consistency reliability, or the degree to which the instrument agrees with itself. In many other cases, the pilot test would also include construct validity testing. This kind of validity testing is most often done through a two-step factor analysis process, and using exploratory factor analysis, EFA, and confirmatory factor analysis, CFA. This part is quite fun actually, and in our statistics consulting, we love to take on this validation. EFA results in questions loading onto a series as yet of undefined factors. So from here, the researcher is able to derive a definition for each factor, and this would be a construct such as customer satisfaction that you'd like to measure. Then the work of the CFA that follows is to test the hypotheses about those constructs that are devised during the EFA work. It confirms that the exploratory factor analysis has been done correctly. And I know this sounds complex, and it definitely is. And so if you find yourself in the position of needing to take on validation work for a pilot study, then please give us a call or send us an email. We can provide precisely the consulting that you need to move forward successfully with your statistical methodology. And this is help that we provide each day actually, and we're happy to do it. Once this has been resolved for you, you can start to think and make decisions about research design. Again, this will be discussed right after methodology in your foundational work and methods chapter. For quantitative designs, there are 5 main options: descriptive, correlational, causal comparative, quasi-experimental, and experimental. Descriptive. A descriptive study does as it says. It describes. Specifically, it doesn't have an independent variable, but rather a group of participants that form the unit of study. Now let's apply this to our investigation. We're looking at self-efficacy as a function of participation in a peer mentoring program for first semester undergraduate students. So, a descriptive study would analyse levels of self-efficacy in a unit of analysis or a group of students who've participated in that peer mentoring program. In terms of analysis, it would proceed with descriptive statistics. For continuous data like self-efficacy scores, this typically includes minimum, maximum, mean, median, and standard deviation. Often this design isn't sophisticated enough for a doctoral dissertation, and we can help you to add refinement by adopting one of the other designs I'll talk about. Correlational. Next is correlational. A correlational study takes on just a little bit more complexity in the form of one or more independent variables. Just like a descriptive study, it will have one or more dependent variables. But to measure correlation, you'll have to examine that dependent variable with reference to another variable. Again, the independent variable. Now, I'll stress here that the correlational design studies measure correlation. They don't determine causation. And let's see it in terms of a study that we might conduct. So let's say that we want to determine the relationship between a participation in a peer mentoring program, independent variable, and a change in self-efficacy, dependent variable. Now, it would be possible to administer a self-efficacy survey to a sample of students before they began the program, and then provide the same assessment after completion of the program. In this case, we would compare student self-efficacy scores at the pre-program stage with scores at the post-program stage to determine if a relationship exists between experience of the peer mentoring intervention and self-efficacy. Again though, causation would not be determined here, and this is in part because of confounding variables. It could be that other factors, class participation, meeting new people, simply time at school, could play a role here as well. Controls on these variables for your dissertation help to increase its sophistication. A causal comparative study is next. It's one that, well, you've guessed it, involves comparison. Now, here there are independent and dependent variables still, and that will be the case going forward as well. And in many ways, the causal comparative design resembles the quasi-experimental and experimental designs that we'll discuss in a moment. Now, what's different about a causal comparative study, though, is that it examines differences that already exist between or among groups of people. In other words, the groups can't be manipulated by the researcher. Gender is a great example of this. A researcher can't select genders for participants. For our sample study, a causal comparative version of it might be one where increases in self-efficacy from the peer mentoring program are examined as a function of gender. That is to see if male and female students respond differently to the peer mentoring program. And you'll notice that this study has now got a lot more complex. Candidates can sometimes struggle when getting to the design portions of their dissertations and reach out for help from a statistician, and we're here to provide it. Now, as I hinted at above, experimental and quasi-experimental studies feature one or more independent variables that can be manipulated. And what's great about this is that we can begin to arrive at causal links between or among variables this way. Now, I should mention that quasi-experimental studies, though, are not fully experimental because they lack random assignment, meaning that the researcher can't decide randomly to place some participants into the experimental group and others into the control group. So what situations might this happen in? Well, let's apply it to our sample study. Let's say not all students participate in the peer mentoring program. As a result, we have two treatment groups to compare in the form of an experimental group and a control group. Again though, the researcher can't pick who participates and who doesn't, as it's an optional program. In true experimental design, random assignment is able to happen. And there are many examples of this. And in a science fair, students begin practicing it right away. An example might be randomly assigning young plants to a rock music group, a classical music group, or a control group, and then administering the treatment. We have variables here, and the difference between this design and a quasi-experimental one is that random assignment. It makes for a stronger study because it helps to control for confounding variables, perhaps levels of sunlight, days elapsed before seed germination, and other things. Now, what's tricky about our sample study about the peer mentoring program is that true experimental design can sometimes not be allowed. And we see this particularly in education. There are concerns about research ethics, particularly when it comes to withholding from students something that is potentially beneficial. But let's put ethics aside and say that hypothetically, random assignment were possible here. Through that random assignment in your dissertation, you can help to control for potentially confounding variables. And believe me, there are many, including high school GPA, IQ, first-generation college status, race, ethnicity, socio-economic status, and many, many others. I know that while I've explored with you just now the main options for selecting a research design, It's not always straightforward. And like I've mentioned a few times so far, you can choose any quantitative design in an ideal world. But it's not an ideal world. Ethical boundaries and simple practicality will close off options for you. There might not be an easily established control group, for instance, or you might not be able to gain approval or access all of the data that you might want to gather. Understanding exactly what you're after then, as well as what's possible and how to easily classify that, is something that we can assist with if it's a struggle for you, or even if you just like confirmation from a statistician that you're doing it right. We can definitely help. That assistance starts back at the topic development stage, where we can work with you on some of these questions, providing strategic help to get you off the ground and moving forward all the way through to dissertation editing. And regardless of the stage at which we start with you, we would work to final approval at no additional charge for this reason. And please reach out, we'd be happy to hear from you. Thanks for watching.